Very good morning, my dear friends. In today's video, we are going to learn about drawing the development of a hexagonal prism, which is resting on one of its hexagonal ends on HP with a side of that parallel to VP, and that is being drilled with a hole perpendicular to the wall or VP, such that the axis of the hole bisects the axis of the prism. They meet at the midpoint of the axis. So, for the given condition, friends, let us place the prism on HP such that a shorter edge is parallel to VP, obtain its top and front views. So, I have written the XY line. Here I am going to write down a regular hexagon of side equal to 30 mm is a regular hexagon we have got, and we have this side is equal to 30 mm. All these sides measure 30 mm each, and let us obtain the front view of that by projecting all these lines from there. So this is how we get the top view, and in the front view we are going to get a rectangle, and these two edges are also seen there. So this gap and this gap will be seen. We will locate the center of this and write down the axis of the solid, and let's mark this like this. This is AA1, BB1, CC1, DD1, E1, FF1. This is O comma O1, and here you have got A dash, B dash, C dash, D dash, E dash, F dash. This is O dash and O1 dash. Similarly, for the bottom piece, we have A1 dash, B1 dash, F1 dash, C1 dash, E1 dash, and this is D1 dash. This is the axis O dash, O1 dash. Friends, now we know when the hexagonal prism is spread on its lateral surface, you are going to have in the development a rectangle having width is equal to 30 into 6. 30 is the side of each, and 6 sides are there. So we are going to get it as 180 as the length, and height of this object is given to be 80 millimeter. So I am going to mark that height in the print view. Now the hexagon has got 6 rectangular faces. So I am going to have 6 such rectangles here. Each of these measures 30 mm. So we have 6, 1, 2, 3, 4, 5, 6 such rectangles on the lateral surface. Let me mark this as A, B, C, D like this. This is capital E, B, C, D, capital D, E, F, and again A. The starting and the end point should be same. This is A1, likewise A1 here. This is B1, point C1, D1, E1, and F1. We'll mark this dimension as 30 mm. So each of these will have 30 millimeter, and the total length of that is going to be 30 into 6. 30 multiplied by 6, that is 180 millimeter. That is the length of that, or the width, whatever you call. Friends, now a hole is drilled at the mid height O dash, O1 dash on this face. So the axis of the hole, which is drilled perpendicular to VP, bisects the axis of this. So I am going to take midpoint of this height, that is totally 80. I will take or mark a point at a distance of 40 millimeter from the base. So this is 40, and from here I am going to write a circle or a hole of diameter. How much it has got? Diameter of a hole of diameter. This is 30 by given 40. 40 is drilled here. So friends, this space is 30. 40 means 20 mm radius. I am going to draw a circle here. I am going to draw a circle of radius equal to how much? 20 mm. So radius 20, diameter is 40. Now friends, whenever you make a hole on a flat surface which is parallel to you, on that face, for example here, if you are drilling the hole on the face BC, B1, C1 here, so you will be able to see a circle up to this height. That is, I will take a point from here, and this hole is drilled exactly between BC, that is this gap BC. So friends, I will take the midpoint of that BC, and then I will draw two lines from the edges of this hole. So friends, this point is this point. I will call it as point 1. Say this is point 1. Similarly, the opposite to that is point 2. We will call this as point 2. That is the extreme corners of this hole. Friends, the hole is drilled there. Let us see where that hole is seen in the top view. From this end of the circle, friends, I am going to write a vertical line downwards. So it is cutting here and here. Similarly, on the other end also at the same height, we are going to get 2 points. So this is cutting here and again here. These two will be on the same line. Friends, you have marked point 1 and 2. And here, the extreme end is here. Now how to locate this? I have written a vertical line from there. And here, friends, the measurements of AB, BC, CD, DE, all are these are true lengths or actual measurement. So friend, what I do to get the extreme end of this hole in the development, I have written the vertical line, and this is cutting this AB at this point. You can take this measurement on AB and also on AF and draw two vertical lines on AB and also on AB and AF. We will see later on. So friends, we are going to get this point here. If we extend the center, this is the other extreme end. Similarly, from the center on the other end, if we extend this, we can also mark the same distance here. So friends, we have got 1, 2, 3 and 4. These 4 points we have got. So now a curve passing through this 4 point should give you an ellipse, and for this ellipse, this diameter of the circle or the hole is the minor axis, and this will be more here. Friends, now to get a better curve or a smooth curve, you have to have some more points in between that. So what we can do, friends, on this BC or AB, we can take some point very closer to this, some point here. Take that measurement on BA near to B. So I am going to take that point here, draw a vertical line here, and a horizontal line from where it is cutting. So it is cutting somewhere here. So I will just write a vertical line here, friends, till here, and it is cutting here. So I will just Draw a horizontal line through that and obtain this point. This is one of the points. So you got 1, 2, 3, 4. We got one more point here. Similarly, friends, on the other end, at the same distance from this, you can have one more point here, one more point here. Likewise, symmetrically on the other end, you will have the point here, one here, and also one more here. Friends, join all these by smooth curve. What happens? There's an important point to be noticed here. Friends, this rectangle BCC1 B1 is parallel to you or parallel to VP. And here this is the center of the ellipse. Since this distance is the radius, since it is on a flat surface, and you are going to get an exact circle here. That is to say, you can join this point by a smooth curve from here, BB line to CC line. These are the points. So you can take a compass and draw an arc like this. Similarly, the bottom face also you can have an arc. That is with center O and radius equal to, say, this radius, which is equal to the radius of that is 20. You can write one more curve here. Friends, we are going to have symmetrically on the other end also. Friends, the remaining points, whatever you have got there, are to be joined by smooth curve. So this part I am going to join by a smooth continuous curve. Similarly here, we are going to join by a smooth continuous curve like this. So friends, you will be having a portion on the rectangular face as exact arcs, and the points outside this will be smooth curve like this. Friends, this is how the hole drilled on this surface, that is BC B1C1 looks. This is how you get on that surface. Friends, here you have to darken only up to here, and this portion is removed, but you have to show by thin lines. Friends, whatever the portion you are getting here, an exactly similar curve you are going to obtain for the other end. That is to say, on EF, on EF, exactly in the center of that, on EF, you can just write a line exactly in the center, mark that points, same line. So this is the center of that circle again, and whatever the radius you have got, you can take this as center, and you can draw an arc passing through this. Similarly here, the bottom surface, you can have one more. So this is going to be an arc, that is this radius 20 mm. I have taken, I can just mark it as 20 radius. This is 20 R radius. So friends, here these points can be located, that is, what are the distance from 0 to 3 or 0 to 4. You have to take these two ends here, and you will join them by same, all these points to be located and joined by a smooth continuous curve. It's going to be a smooth continuous curve. This is the radius 20 mm. Friends, after completing this, let us darken the borders, the outlines of the figure, and again at the bottom you can have it. Here, this has to be darkened up to here, that is, this is up to here. Have to darken it, darken that. This is to be shown by vertical line DD to be shown here like this. And friends, this is how the hole drilled on the hexagonal prism perpendicular to the plane of the board looks in the development. Friends, I hope the presentation was interesting, and if you like this video after going through it completely, please subscribe to my channel and forward the message to all your friends. Have a wonderful day. Thank you.